This is the problem, we have to solve it. Here let P be a point in the first quadrant lying on the ellipse whose equation is given as x square over 8 plus y square over 18 equal to 1. Let AB be the tangent at the point P to this ellipse which cuts x axis at A and cuts y axis at B. O is considered as the origin. What is the minimum possible area of the triangle OAB which is formed by this tangent and two axes? Now, we have to determine the minimum possible area of this triangle OAB. Now, let us start. At first, we shall draw the figure diagram of this ellipse. This is the ellipse. These are two axes of the ellipse. This is horizontal axis, x dot is considered as major axis, and this vertical axis considered as minor axis. This is the ellipse. This is the ellipse. This is the ellipse whose equation is given as this. Now, P be a point in the first quadrant, that is here the point P, and also we can take the parametric coordinate of this point P for this ellipse, and this parametric coordinate is a cos theta. Here a is root 8 and A means the length of semi major axis. Length of semi major axis is considered as A. Length of semi minor axis is considered as B. Here A is root 8 and B is root 18. So, parametric coordinate is A cos theta, that is root 8 cos theta, and root 18, B means root 18, that is root 18 sin theta. This is the parametric coordinate of the point P on this ellipse, and also a tangent is drawn at this point P, and this is the tangent. This is the tangent, and this tangent cuts x axis at A, and this tangent cuts y axis at B. Cuts x axis at A and cuts y axis at B. This is the tangent AB, and also the O is the origin of the axis, that is intersection of two axes is considered as O, which is called origin. This is the origin, O is the origin, and we have to determine the minimum possible area of the triangle OAB. This is the triangle OAB which is formed by this tangent and two axes. Now, we can write the equation of the tangent AB. Equation of the tangent at P, whose coordinate is considered as root 8 cos theta, root 18 sin theta, is equation of tangent. We have already known the formula of tangent to the ellipse: x square over a square, y square over b square at parametric coordinate P, whose coordinate is a cos theta. Parametric coordinate at P, a cos theta, b sin theta, is equation of tangent is taken as x cos theta over a. Here a is root 8, y sin theta over b. This is the equation of tangent at a cos theta, b sin theta to the ellipse x square over a square plus y square over b square is x cos theta over a plus y sin theta over b is equal to 1. We have already known the formula for this tangent. Here this is also a tangent. This tangent is also a straight line. This is the equation of straight line, and we have known the intercept form of any straight line. So we can convert this equation into intercept form. We can by converting the equation 1 into intercept form. We can convert the equation of any straight line into its intercept form. This intercept form is x over a means root 8 cos theta over cos theta plus y over root 18 over sin theta. This is equal to 1. This is the intercept form of any straight line. This intercept form is x over a plus y over b is equal to 1. Here a is x intercept and b is y intercept. This is x intercept, this is y intercept. So x intercept is the length of OA. Here a is the point of intersection of the tangent and x axis and O is the origin. So length of OA is called x intercept. So x intercept is the length of OA, that is OA is equal to this. This is the x intercept. So this is x intercept, and also y intercept OB. Y intercept also OB. This is the length of OB. OB is the y intercept, and here B is the point of intersection of the tangent line and y axis. This is the point of intersection of tangent and y axis, and this is origin. So distance between O and point of intersection of tangent and y axis is called the y intercept. So OB is the y intercept, and also y intercept is this. This is the intercept form of this straight line. So OB is this root 18 over sin theta. This is the y intercept. Now we can easily calculate the area of this triangle OAB. So area of triangle OAB is considered as M equal to area of any triangle is half multiplied by its base and multiplied by its altitude. Half multiplied by its base. Base is OA. OA is the base of triangle OAB. So this is OA multiplied by its altitude. OB is the altitude of this triangle OAB. So this is OB. So this is the area of the triangle OAB, which is considered as M, and half OA. OA, value of OA is this, that is multiplied by root 8 cos theta, and value of OB is also this, root 18 over sin theta. Root 18 over sin theta. This is equal to root 18 is root over of 144, which is 12. So 12 over 2 is 6. This is the area of the triangle OAB, which is considered as M. M is equal to this. M is the area of this triangle OAB. Now we have to minimize the area M. We have to minimize the area of the triangle OAB, which is considered as M. For minimization, of M, first derivative must be 0. This is the rule for minimization, which is known from calculus. This is the rule for minimization. Rule of minimization is first derivative of the quantity is 0, and also we have to show that the second order derivative of m with respect to the variable must be greater than 0 for confirmation of minimization. For minimization or maximization, in both cases first derivative of the quantity must be 0, that is dm d theta must be 0. dm d theta must be 0. This is the condition for minimization, this is the necessary condition for minimization or maximization. This is dm d theta equal to 0. So, we can differentiate m with respect to theta. Here d d theta of 6 over sin theta cos theta equal to 0. This is this derivative differentiation is this sin theta cos theta square, denominator multiplied by the derivative of 6 numerator, derivative of numerator minus numerator into derivative of denominator sin theta cos theta. This is the rule for differentiation of function in the form of division. So, this is 0, d d theta of 6 is constant, so this is 0, only this term remains. So, minus 6, derivative of this is cos square theta minus sin square theta over sin theta cos theta whole square, this is equal to 0. So, this implies this is the formula for cos 2 theta. So, we can write this as cos 2 theta, cos 2 theta is equal to 0, cos 2 theta is equal to 0. And for the solution of this trigonometric equation, we get solution of this trigonometric equation is 2 theta is equal to pi over 2, 3 pi over 2, 5 pi over 2, etc. Also plus minus. So, theta equal to plus minus pi over 4 plus minus 3 pi over 4 plus minus 5 pi over 4, etc. These are the solution of theta. These are the solution of theta. These are the solution of theta. As p lies in the first quadrant, so theta only theta equal to pi by 4 is accepted. All other values are rejected because theta lies between 0 and pi by 2. Theta lies between 0 and pi by 2. Pi by 4 lies between 0 and pi by 2. So, only theta equal to pi by 4 is accepted. Others are outside the range 0 pi by 2. Others value of theta lie on the outside of the interval 0 pi by 2. So, those are rejected, only theta equal to pi by 4 is accepted. As p lies in the first quadrant, theta equal to only pi over 4 is accepted. Now, we have to verify the sign of second order derivative for confirmation of minimization, and also for confirmation of minimization, second order derivative of m with respect to theta at theta equal to pi by 4 must be greater than 0, that is positive. We have to show it. So, for confirmation of minimization, we have to show d2m d theta 2 at theta equal to pi by 4 must be greater than 0. We have to show it. If we are able to show it, we shall say that the M, that is area of the triangle OAB, is minimized, will be minimized. So, we have to further differentiate dm d theta. So, d d theta d2m d theta 2 at theta equal to pi by 4 is equal to further differentiation of dm d theta equal to pi by 4. This is equal to d d theta of dm d theta. Dm d theta is we have got this result, that is minus 6. Dm d theta is minus 6 cos 2 theta over sin theta cos theta whole square. This is dm d theta. This is dm d theta. So, minus 6 cos 2 theta over sin theta cos theta whole square at theta equal to pi by 4. This is equal to d d theta of, we can multiply both numerator and denominator by 4. So, we get minus 24 cos 2 theta over denominator, after multiplication denominator becomes sin square 2 theta. We have multiplied both numerator by and denominator by 4, and we have got this result, that is minus 24 cos 2 theta over sin square 2 theta. So, differentiation of this quantity is equal to denominator square, that is sin square 2 theta square, denominator multiplied by derivative of numerator, that is d d theta of minus 24 cos 2 theta minus numerator, that is minus 24 cos 2 theta multiplied by the derivative of denominator, that is d d theta of sin square 2 theta. This is, so we get sin square 2 theta. Derivative of this quantity minus 24 cos 2 theta is minus 24 multiplied by 2 multiplied by minus 1 sin of 2 theta, that is 48 sin 2 theta. This is the derivative of numerator, that is minus 24 cos 2 theta minus plus, that is 24 numerator is minus 24 cos 2 theta. So, minus plus 24 cos 2 theta multiplied by the derivative of denominator, which is 2 sin 2 theta multiplied by this 2 cos 2 theta. This is over sin square 2 theta square, that is sin 4 2 theta. This is equal to 48 sin cube 2 theta plus 96 sin 2 theta cos square 2 theta. 96 sin 2 theta cos square 2 theta over sin 4 2 theta. this is, and also value of this at theta equal to pi by 4, theta equal to pi by 4, theta equal to pi by 4, theta equal to, we have to find the value of this quantity at theta equal to pi by 4. So, value of d2m d theta 2, d2m d theta 2 at theta equal to pi by 4 is equal to theta equal to pi by 4, that is 2 theta is pi by 2, sin square pi by 2, sin cube pi by 2 is 1, 96 sin 2 theta means pi by 2, sin pi by 2 is 1, but cos square pi by 2 is 0. 2 theta is pi by 2, but cos square pi by 2 is 0. So, this term vanishes, only this term remains, and the value of d2m d theta 2 at theta equal to pi by 4 is 48 sin 2 theta sin pi by 2, because theta is equal to pi by 4. So, 2 theta equal to pi by 2, that is sin pi by 2 cube, sin cube pi by 2 over sin 4 pi by 2, which is 48, which is greater than 0. Sin pi by 2 is 1, and this term vanishes because cos square pi by 2 is 0. So, we have got the value of d2m d theta 2 at theta equal to pi by 4 as positive. We have got positive value of d2m d theta 2 at theta equal to pi by 4. That is, second order derivative of the quantity m with respect to theta at theta equal to pi by 4 is positive, is strictly positive, that is greater than 0. So, the minimization is confirmed, that is, the minimization is confirmed. So, the minimization of m is confirmed. So minimization of m is confirmed at theta equal to pi over 4. So, minimum value of m. So, m minimum value of m is equal to value of m was 6 over sin theta cos theta, and at the value at theta equal to pi by 4, this value is the value of the area is the minimum value of area is 6 over sin theta cos theta at theta equal to pi by 4. This value is 6 over sin pi by 4 is 1 over root 2, cos pi by 4 is 1 over root 2. This is equal to 12 square units. This is the minimum possible area of the triangle, that is minimum area of the triangle OAB, minimum possible area, minimum value of area of this triangle OAB, which is formed by the tangent to the ellipse and two axes of this ellipse, and this minimum value is got as 12 square units.